Now you have a math test that's coming very soon, and you have troubles with derivatives. Now, what if I told you you can be able to derive anything under 10 minutes? Because I know you like to study during the last minutes, which is the method that I don't recommend. But what if it's already too late and now you want to learn the quickest ways you can derive functions? Well, I have a list of formulae I want to give you. The first one, which you already know, it's ax to the n. When deriving such functions, you're going to have an times x to the power n minus 1. This means if I'm deriving 2x to the third, the derivative of this is going to be 2 times 3. Is this 2 times this one, which is going to be 6. And you say to the exponent and you subtract 1 from it. Then you're going to have 2. So that's the first formula you must know. The second one you must know is that if you are deriving a function raised to some number, raised to a constant, if you're deriving a function raised to a constant, some number there, you're going to have n times the first derivative of f times f of x to the power of n minus 1. What this means is that if you are deriving x, 2x minus 6 to the power of 3, the derivative of this is going to be 3 multiplied by the derivative of what's inside, which is going to be 2. And then you're going to have, copy the thing as it is, 2x minus 6, and you say to the exponent, you subtract 1. 3 minus 1, that's 2. So that's just the derivative of this. That's how you can derive that. The third one I would like to show you guys is if you're deriving the square root of a function. If you're deriving the square root of a function, the derivative of that is going to be the derivative of what's inside the square root divided by 2 multiplied by the whole thing. What this means is that if you're deriving the square root of x squared plus 2, the derivative of this is going to be the derivative of the inside. The derivative of x squared is 2x. The derivative of 2 is 0. So you're just going to have the derivative of f as 2x. And you're going to divide that by 2, multiplied by the square root of x squared plus 2. Now notice that the 2's cancel. And you're going to have x divided by the square root of x squared plus 2. So that's how you can derive any function that's inside the square root by just memorizing this formula. The other rule you must be familiar with is deriving the natural logs. If you are deriving the natural log of some function, this is going to be the derivative of that function divided by that function. What this means is that if you are deriving the natural log of e to the x, this is going to be the derivative of e to the x is e to the x. It stays the same, and you divide by the function, which is e to the x. Notice that this will reduce to 1. Another example on this, I can say a ln of 2x. If you are deriving this, you're going to derive the inside, which is 2, and you divide by 2x. Notice that the 2's will cancel, and you'll have 1 over x. So that's how you can derive this. Now, what if you want to derive something else? For example, you want to derive 1 over f of x. The derivative of this is going to become minus the first derivative of f divided by f of x squared. This means that if you are deriving 1 over x squared, this is going to be the derivative is going to be negative. You say the derivative of x squared, which is 2x, and you divide by this square, which is x squared squared. X squared squared just means that x squared times x squared. Notice that this x will cancel one of the squares, and you'll have 2. Still have that negative, you'll have 2, and you'll have x squared times x, which is x to the third. That's how you can derive this. That's how you can derive this. For example, another example might include 1 over x. If you're deriving 1 over x and you use the formula, you're going to have minus, and the derivative of x is 1. And you'll have x squared. Now, I'm not going to go through those exponential formulae. check out my videos on exponential formulae. This is just basically the stuff that I covered there. This is gonna be a to the p, a to the b into a times b prime ln a plus ba prime divided by a. And here I have a to the power f of x. And if I'm deriving this, is gonna be a to the f of x multiplied by the derivative of f multiplied by the natural log of a. And if I have e, it's going to be e to the power of f multiplied by f prime. So check out my video of exponential functions on this one. I'm not going to go through it again. The other ones include like having sine of a function, sine f of x. So the derivative of this is going to be f prime multiplied by cos f of x. What this means is that if I'm deriving sine 6x, if you're deriving sine 6x, you're going to derive 6x, which is 6, and you multiply by cos of what's inside, which is 6x. If you have sine of x squared, this means you're going to derive x squared, which is 2x, and you're going to have cos of x squared. That's what this means basically. The other one you're going to have is cos f of x. I'm going to have cos f of x, which is minus the first derivative of f multiplied by sine f of x. What this means is that if you have cos 2x, this is going to be minus the derivative of 2x, which is 2, multiplied by sine of that, which is 2x. So that's what you're going to have. Now, what if you're deriving tangent of f of x? This is going to be the same as the first derivative of x multiplied, the first derivative of f of x multiplied by secant square of f of x. So that's how you can derive this. Now, notice that I have, when I give an example here, let's say I have tan 3x minus 2. This is going to be the first derivative of this, the derivative, the inside, which is 3. You're going to multiply by secant square of that 3x minus 2. So that's what this means. Now I'm not going to go through cosecant, secant, and cotangent. Those ones you can just go and memorize them. Or you can use this formula. Since you know that secant, this is 1 over cos. That means that if you are derivating secant, you can use 1 over cos and use this formula. You won't go wrong. Now let's say you're deriving inverse trig functions. Let's say I'm trying to find the derivative of arctan 3x. The derivative of this is going to be the derivative of the inside, which is 3, divided by 1 plus 3x squared, which is going to be 3 over 1 plus 9x squared. Now deriving our cos f of x, for example, our cos x squared, when you find the derivative of this, is going to be minus, you derive the inside, which is x squared, which is going to be minus 2x, and you divide by the square root of 1 minus the square of that function, which is going to simplify to minus 2x divided by 1 minus x to the 4th. Now what about arc sine f of x? If you're trying to derive this one, let's say you're trying to find dx of arc sine, the square root of x. This is going to be the first derivative of the square root of x, which is 1 over 2 root x. Then you divide this by the square root of 1 minus the square of the function, in this case it's root x. Then you'll have root x squared, which this will simplify to 1 over 2 root x multiplied by the square root of 1 minus x. So that's how you can derive this. That's how you can derive such inverse trig functions, basically by just memorizing this formulae.